Find intervals of increase and decrease and the local maximum and minimum values for x cubed minus 3x squared minus 24x plus 2. Okay, the classic shape for a cubic looks kind of like a lightning bolt or like an S turned over, something like this. And that's what we have here. It's something with a third degree and a positive leading coefficient, so probably a shape something like this one. And we want to find where is it going uphill, that would be this section and this one. Where is it going downhill, this section in the middle. Where is its local maximum, that would be the top of the hill here. And where is its local minimum, which would be the bottom of the valley right here. And the derivative can do all of those things for us, because derivative is slope. So let's get a derivative and then we'll ask it some deep questions. df dx, this is a polynomial, so the derivative is a snap. 3x squared minus 6x minus 24. Okay, the way we start a question like this is by finding where the derivative is 0. Because if you know where the zeros are, from there you can work out where are the positive areas and where are the negative areas. But we start out by saying, take the derivative and set it equal to 0. Well, that whole thing is divisible by 3, so let's make that happen. X squared minus 2x minus 8 equals 0. That's factorable, which is lovely. X minus 4, x plus 2 equals 0. And so that gives us either x is 4 or x is negative 2. So we thought there might be 2 points where the derivative was 0, and indeed there are. They are 4 and negative 2. The next question is, how is the curve behaving around those points? Now, I kind of gave that away by drawing this sketch, but let's pretend we don't know that. Pretend all we know for now is that the function is flat at negative 2 and at 4. So the plan is, we're doing a number line that has minus 2 and 4 on it. And we want to know, where is this derivative equal to 0? Where is it greater than 0? And where is it less than 0? Which means we're going to evaluate its pieces, which are x minus 4 and x plus 2. We'll see what their signs are, and then we'll combine them and see what the overall derivative has for a sign. So, if we're out here where x is lower than minus 2, you can think of it as minus 3 or minus 10 or whatever makes you comfortable. Lower than minus 2, minus 4 would come out negative. A number lower than minus 2, if you add 2 to it, would still come out negative. And negative times negative means the derivative overall is positive out here. If we were exactly at negative 2 minus 4 is negative. Negative 2 plus 2 is 0. Multiply those and you get 0. If x is between negative 2 and 4, let's say it's 0, that's easy. 0 minus 4 is negative, 0 plus 2 is positive. Multiply those together and you get a negative result. If x is exactly 4, 4 minus 4 is 0. 4 plus 2 is positive, 6. And 0 times a positive number is 0. And finally, if x is bigger than 4, you can think of it as 5 or a million or whatever you want. I'm doing 5. 5 minus 4 is positive. 5 plus 2 is also positive. Multiply those and you get a positive result. So this says the derivative, meaning our slope, should be positive, 0, negative, 0, positive, which means on our curve we should be going uphill, flat, downhill, flat, uphill. And sure enough, there's uphill, here's flat, downhill, flat, uphill. So the derivative predicts every curve that this function is going to take. So if we're looking for intervals of increase, the intervals of increase would be everything up to negative 2 and then everything above 4. Intervals of decrease This is the only interval of decrease. Between -2 and 4, the function is decreasing, meaning it's going downhill. How do you find a local maximum? Well, imagine if you're walking with your eyes closed. How would you know when you're passing the top of a hill? You'd feel that you're going uphill, and then you'd feel the ground flatten out, and then you'd feel it start to drop away. Every time that happens, you know you've just gone over the top of a bump. So, as far as the derivative is concerned, the top of a hill means the derivative is positive, then it hits 0, and then it goes negative. And that happens right here. Meaning around -2, we have a maximum. This point is uphill, flat, downhill. So we consider it what's called a local max. If you're passing the bottom of a valley while walking, you should feel the ground go sloping down, then flat, then sloping up. And we have that happening around 4. So 4, as our graph already told us, is the bottom of a valley, or what we call a local minimum.